Back in the early days of our lockdown, I did a high production video for AP Statistics. It was a little bowl of those paper cutouts, when you have a hole punch and you get we collected them, and I rolled up a piece of paper, made a tube, and I was going to show the distribution of particles as I expressed them out through a simulated cough or sneeze. And one of the things I learned is you don't inhale before you do it. I took an inhale on the first take and got about a half a dozen of those things down my throat. So with my wife tending the video, there you go. That's my distribution of paper particles. And I made a talk about describing a distribution, which you guys now know is a center and a shape and a spread and outliers. But the question comes down to, and the context of the question comes down to social distancing. From a statistical perspective, you've got issues such as temperature change. Is the sneeze or cough happening inside or outside? Is there wind involved? What's the weight of the particles? What's the mix of the particles? What's the concentration of the mix? I mean, if you're just getting just generic saliva, that might be icky, but it doesn't mean it's going to get you sick. Well, in a more high-tech presentation, I found this on the internet. I don't recall what school these guys are at, but they've got some fancy lighting and some water droplets, and they're doing the same thing I did in my living room. And they've got a certain measuring device that I think you'll see it in a little bit, that records how far the sneeze goes, how long it lingers. The statistical component looks at the distribution and likelihoods of catching. I mean, you could catch more than one thing. I mean, it might be the common cold, it might be influenza, it might be measles, it might be COVID-19. You could get all of those from one sneeze because you're not okay. Here comes my influenza cough followed by my COVID-19 sneeze. So, and just because you get the particles doesn't mean you're necessarily going to get infected by them. So then the calculus comes in when you look at this distribution and you look at the risks involved. What's the optimal public policy distance that assures public safety balanced against a viable economy? So there you go. This is too complicated of an issue for me to expect you to answer in one simple Schoology post. So how about if we make it your summer assignment? Those of you taking AP Stats next year, you guys up for this? Maybe not. If you're feeling ambitious, knock yourself out. Otherwise, thanks for hanging in with me this year. I look forward, hopefully, to seeing you guys live and in person next year. Signing out.